Today we will go over section 11.3, day 3. Our learning target is to find the area of a segment of a circle. We will need to recall from yesterday the formula for finding length of an arc. We will also need to recall the formula for finding area of a sector. A segment of a circle is a region bounded by an arc and its chord. So how do we find the area of the segment? We're going to take the area of a sector and subtract the area of the triangle. So you can see here this orange triangle. When we remove that piece, we are left with just the segment. So we're going to go through these steps to find the area of segment LNM to the nearest hundredth. So starting off with step 1, we need to find the area of sector LNM. So we will start by setting up this proportion. We take the degrees of our intercepted arc measure, which is 120 degrees, over 360 degrees. We set that equal to A to represent the area of sector LNM over the area of our circle. Recall that the area of a circle we can find by taking pi times our radius squared. So in this case, our radius is 9, so we would say pi times 9 squared. Once you have your proportion set up, we can cross multiply, taking 360 times A and setting that equal to 120 times pi times 9 squared. So that gives us this step right here, 360A equals 9,720 pi. Then, to get A by itself, we can divide both sides by 360. And that gives us the area of sector LNM equals 27 pi. Moving on to step 2, we need to find the area of triangle LNM. And we're going to draw altitude NO, because that will be our height. So we basically just took this triangle LNM from our circle and redrew it over here. Remember that the measure of our central angle was 120 degrees, okay? So if we draw in that altitude, NO, that is bisecting that angle. So that tells us that each of these two angles is 60 degrees because 120 divided by 2 equals 60. So since we know that that angle would be 60 degrees and we have a right triangle, that makes our third angle 30 degrees if we subtract both of those from 180. So we do have a 30, 60, 90 triangle in this case. So we can use the formulas that we know for 30, 60, 90 triangles. We are given that LN and NM are both 9 because that is our radius. And remember, if you put your formula on the triangle, our hypotenuse is equal to 2 times our shortest side. So to find our shortest side, or our height, we have 2s equals 9. We can divide both of those by 2, and that gives us s equals 4.5. So that's how we get our height, NO, equals 4.5. Then, to find our longer of the two legs, we take our short side, 4.5, times the square root of 3. So that's how we get 4.5 root 3 here. Okay, so now that we know both our base and our height, we can plug these into the area of a triangle formula. So we have 1/2 base times height. Our base we can find because we know that each of these parts is 4.5 times the square root of 3. So if we add those together, 4.5 root 3 plus 4.5 root 3, that equals 9 root 3. So that's our base. And then our height, which we have already discussed, was 4.5. So we have 1/2 times 9 root 3 times 4.5. You can go ahead and type all of that into your calculator. If you want to leave the square root of 3 to the side, you can do that and just multiply 1/2 times 9 times 4.5, and that gives us the area of our triangle, which is 20.25 times root 3. Okay, step 3, we find our area of our segment by taking the answer that we got in step 1, the area of our sector, and subtracting the answer we got in step 2, which was the area of the triangle LNM. So we have 27 pi minus 20.25 square root of 3, and you can go ahead and type all of that into your calculator and round to the nearest hundredth, because that's what our directions said to do. So go ahead and do that, and you should get 49.75 centimeters squared. All right, we're going to go over one more example. So this time we're going to find the area of segment RST to the nearest hundredth. Starting with step 1, find the area of sector RST. So we can set up a proportion. We have it marked in our triangle that this is a right triangle, so we know that that measure of the intercepted arc would be 90 degrees. So we have 90 over 360 on one side of our proportion. And then on the other side of our proportion, we have A for the area of our sector, which we're going to find, over the area of our circle, which we find by taking pi times r squared. Our radius in this case is 4 meters, so we have pi times 4 squared. Now that we have our proportion, we can cross multiply. 360 times A equals 90 times pi times 4 squared. So we have 360A equals 1,440 pi. Next, to solve for A, divide both sides by 360, and the area of our sector equals 4 pi meters squared. Moving on to step 2, we need to find the area of triangle RST. In this case, since we have a right triangle, we do know our base and our height. And I'll draw that out for you off to the side here so you can see that a little bit better. Okay, so we have a right triangle, and we know that ST is 4 meters, and that was our radius. And remember, RS is also a radius, so those would both be 4 meters. So since we know our base and our height, we can plug those both in. We get the area equals 1/2 times 4 times 4. So the area of our triangle is 8 meters squared. Lastly, step 3, we take the area of our sector, which we found in step 1, and subtract the area of our triangle, which we found in step 2. So we have 4 pi minus 8, and that is approximately 4.57 meters squared.